So welcome back, and now let's continue our topic. And on our last topic, we have learned how to deal with forces that are oriented on an octant or forces that are in 3D. And now let's proceed to another topic which can still be applied on our force vectors, but let us now talk about the equilibrium of a particle. So at the end of this topic, we should aim that we have to identify the different kinds of supports and to draw a free body diagram. So mao na ang atong mga objectives for this lesson. So let us start with Newton's first law. As you can remember, when we have talked about Newton's first law, a particle can be moving at a constant velocity, or probably it is in static if, again, there are no unbalanced force that is applied to that particle. Okay? And that governing equation of Newton's first law is the summation of forces is equal to 0. Okay? And basically, this equation just means that if you are going to sum all the forces that is acting to that particle, the sum of all its forces is just equal to 0. Okay? So, ingana lang ang iyang pasabot ani. Now, on the other hand, if dili mo equal to 0 ang atong particle, then that is accelerating na. Okay? And that will apply to our second law, which is summation of force is equal to ma. But we are not going to deal with this one because this is already a part of your dynamics. Okay, in your next sem nga subject. So, we are more focused on this equation. Summation of forces is equal to 0. Let me discuss to you a very important nga application sa inyo when you are talking about, when we are dealing about particles or objects. This is what you call the free body diagram. I guess some of you are already familiar with this one, and some of you are not. So let me just discuss this one to you in a very brief manner. In statics of rigid bodies, or in engineering mechanics as a whole, in order for you to be able to simplify the problem, or for you to be able to analyze the problem properly, it is best if you are going to draw a free body diagram. Okay, so it just basically means that you have to draw a representation of the interaction of forces. So you have to draw the particle or the body that is subjected to the forces. And when you have drawn the body, then you also have to account and to show all the possible forces that is acting on that body. Okay? So pasabot ana. So, for example, ato kitaon, we have this crate kuntahay. Okay? And this crate is subjected to a force of 100 pounds. This object is said to be in equilibrium. Okay? So this crate is said to be in equilibrium. This just basically means that this is not moving. So, not moving. But if we are going to just see it on this case, ining tanaw nimo diri makaingon ka nga unbalanced force ni kay 100 pounds sa siya padong didto. Dapat unta na pud siya force nga mupugong pud aning 100 pounds para mo equilibrium siya. So that is why making a free body diagram is very important. because you have to account all the possible forces that is acting on that crate. Okay? And in this case, di ay, nganong equal to 0 ni ang atong summation ani nga crate, tungod kay naapatay weight. Okay? Naapatay weight sa atong crate. And because of that weight, there is also a normal force that is going against your weight. Di ba, mo ito ako giingon sa una sa atong first nga lecture that static ko naglingkod sa table tungod kay nag-exert ko og weight sa table, and at the same time ang atong table nag-exert pud og force padong sa ako. And that is what you call your normal force. Okay? So, mao na. But we will not be talking about this one dire, but probably on some other parts or most probably on your physics. Okay? Na-adjud ni sa inyong physics. And sa kaninga case, wala man gihapoy makapugong gihapon aning atong 100 pounds. Ang kaning atong weight, ang atong normal force, equal man ni silang magnitude. Let's say, ang magnitude ani nila kay 200 pounds. So since ang imong normal force ng exert man og same nga amount of force sa imong weight para ma-equilibrium siya, so therefore kanipod 200 pounds po ang iyang i-exert ani. Pero how about diri sa atong kaning 100 pounds? Wala may ni exert og force same aning 100 pounds nato. Kaya kaning atong W og NF kay on the Y direction man ni sila nag-interact. But sa atong 100 pounds, wala may mo equate. Unsa man, ang atong frictional force. And kaning frictional force, probably, it also exerted 100 pound of force. Okay? So, this is your free body diagram of this scenario. I now have accounted all the possible forces that is acting on this crate. And this can only be possible if you are going to draw the free body diagram of this crate. Okay? So, ana lang ka, importante ang paghimo sa atong free body diagram. Before we dive in deeper on how to create a free body diagram, let us first identify different kinds of supports. Okay? So, I have here 3 kinds of supports. Unsa man ang mga support? Mao na sila ang mga nagpugong or nagbira or nag-restrain sa butang nga move. Okay? So, I have here 3 kinds of supports. Our first support are spring support. So, as you can remember, unsa nang spring. So, let's say for example, I have here a spring. Nice ka itong spring, no? And di ba kang kanang spring kay mag-change man na siya length, kay mag-inat man ni siya or mag-contract. Okay? So, let's say, mo ni ang iyang initial length, LO. Ako siya itawag nga LO. So, initial niya nga length. Pero, kung magbutang ko og force, na siya tendency nga mo inat. And let's say, siguro miinat siya at ingani nga length. Therefore, na siya final length of LF. Okay? And now, in order for you to determine the force F nga gi-apply para mo inat ni siya from this point to this point, all you have to do is to use this equation. F is equal to K times S. Okay? In which your K is your spring constant. And usually, this is given in your problem. Okay? Your spring constant. Your S, unsa man ang S? Basically, your S is just the difference of your LF and LO. So, this one is your S. Okay? So, take note, your S is just equal to LF minus LO. Okay? And if you have this one, then you will get your force. So, unsa may unit day aning spring constant nato? Ang unit sa imong spring constant is usually in Newton per meter. Or, pound per inch or foot. And your S has a unit of meter or foot, and once you multiply that one, then you will get a unit of force. Okay? So, yung ana lang pagkuha sa force when there is a spring nga given. And take note, positive ang atong F kung mo inat siya. But, negative ang atong F kung mo contract siya. So, kung mo gamay na noon ang atong spring, then negative na siya. Kaya ang atong LF is less than your LO. That's why negative ang atong F. Okay? Now, on our second kind of support, we have here cables and pulleys. So, unsa man ang cables and pulleys? So, di ba naka-remember mo unsa nang pulley, di ba mo nang atong wheel nga gibitay and then natay cable nga ibutang. Okay? So basically, ang force na ato itawag sa atong mga cables are usually tension. Okay? And in this case, the magnitude of your tension in this point is just the same magnitude sa imong tension dira nga point. Okay? And basically, bisag asa na siya naka-orient, kung nakaing-ana man na or nakaing-ana, the magnitude of your tension is just always equal. If kani kay equilibrium ang atong system or ang summation sa forces is equal to 0. Okay? And take note, we assume that this wheel here is frictionless. So, walay force nga naiban tungod sa aning atong wheel dire kay frictionless ang atong wheel. So therefore, the magnitude of your tension in this point and in this point is just the same. And also take note, so atong cable is always subjected to a pulling force, and that is why you call it tension. Dili siya mo masubject into pushing force kay ngano man mulutay ang atong cable kung ato i-push. Okay? So ingana lang. And for our third kind of support, we have this what we call a smooth contact. Say for example, we have this inclined plane. Okay? And I have here a crate that is positioned on your inclined plane. But take note, ang kani atong inclined plane is a smooth contact. And there is a cable that is pulled right there. Okay? So, therefore, wala na nag-move ang atong crate kaya na may nagbira. And, if you are going to account all these forces nga naa dere, mao ni ang atong weight, okay, sa atong crate. And, we also have a normal force that is always perpendicular to your surface. Take note that your normal force is always perpendicular to your surface. It is not always going against your weight, but it will always go perpendicular sa imong surface. So this is your surface, and your normal force will always go perpendicular to that surface. Okay? So those are the three kinds of supports. Sige daw, let's try to apply those kinds of supports in a problem. We have this sphere. Ang ato lang goal ani nga problem is to make a free body diagram of the sphere, which is this one, of the chord CE, which is this one, and on the knot at C, which is this one. So, mauli ni atong goal sa atong problem to determine and to make a free body diagram of each of those parts. Let's go to the FBD of the sphere. So, sa ato una buhaton, ato i-draw ang sphere. And the goal of our free body diagram is to account all the forces that are acting on the sphere. Okay, so what are these forces? Igtanaw na to diri sa atong drawing, we can see nga ang atong sphere na asay weight of W, di ba? And nakita na to nga kani atong sphere naka-contact siya ani sa atong inclined nga plane. So therefore, we also have a smooth support. Therefore, we have a normal force that is acting in these directions. So, NF and F. And also, lastly, we have this chord CE that is connected to this sphere. So therefore, we have a tension acting at the top portion of your sphere. Okay? Isadong bintana. Isadong bintana. Okay, understood? So this is the free body diagram of our sphere. And since sa atong problem wala man gipangayo ang mga magnitude ani nga mga value ang ani nga mga forces, then let's just keep it this way. Okay? And now, let us make a free body diagram of chord CE. Okay? So, nag-draw ko sa chord CE. Okay? And what are the forces that is acting on this chord? So, we have a pulling force of due to your kanay kuan sphere, and also naapoy pulling force dito padung sa atong knot sa C. Okay? And we have a magnitude of T. Actually, this magnitude of T is just equal to this magnitude of T. Ano man? Kay ang kaning T diri pasabot diri, morning tension nga gibira ang imong sphere by this chord of CE. Pero kaning tension diri paubos naman ni siya tungod kay mao ni atong sphere nga nagbira sa atong chord. So this is just your action and reaction. Diri padung siya didto kay gibira siya sa atong chord, diri paubos siya kay gibira siya sa atong sphere. So mao lang na pasabot ana. Basin mag-wonder mo ngano nag-change ang direction ana. Okay? And now, lastly, the FBD of the knot. Okay? Sa atong knot na pod. So we have this knot at C. So this is your C. And we have a force going that way, which is your spring. And this is your another force dito sa imong cable and pulley. And this is your tension. Tension, this is your T spring. And this is your T pulley. And obviously, these tensions have different magnitudes. So you have to take note of that one. And you can identify the forces of these tensions by our next example. I have here a ring that, I have here a ring that is subjected to a spring, to a cable, and to a force of 600 newtons. And the question in this problem is to determine the forces that is subjected to your A. Okay? So, ato ikuan. Ako iswat ang ring. Ako i-draw ang ring. So, you have this ring nga A. And then, maghimo tag free body diagram ani nga ring A. And ang rule sa atong free body diagram is to account all the forces that is acting on this ring. And as you can see sa atong figure, we have this force of 600 newtons. And this is directed to a slope of 3, 4, and 5. Muna itong first nga force. We have another force nga padong diri, which is ato itawag nga TAB. Kay wala pa man takibaon sa magnitude ana nga force, ato lang sa panganlan og tension sa atong cable AB. Okay, mao nang TAB akong gibutang. We also have a tension that is happening in this side. And let's call it TAC. Okay? So, makontay ni atong problem. This one is directed 30 degrees. And this one is directed horizontal. So, our goal for this problem is to determine these unknown forces. And how can we determine these unknown forces? You can actually create two equilibrium equations with this one. Because, di ba, naaman tayo giingon nga summation of forces is equal to 0. But pwede na to ma-divide into two. We have summation of forces along the x is equal to 0 and summation of forces along the y is equal to 0. And if you have that one, then we can just create our coordinate system, which is your x and your y. Sige, ato unahon og sum ang forces sa y. Summation of forces along the y. Kay para magamit nato atong component nga method nga atong gigamit sa atong mga force vectors. And in this case, we are just adding 3 vectors, but we are now looking for the magnitude of these 2 vectors. And kani siya application na ni sa atong na-learn sa atong previous nga lesson. Okay? And kaning atong summation of forces sa atong y, ako gibuhat ani kay ako lang gi-add tanan nga mga components aning atong kuan. And as you can see, which of these forces has a component of y? We all know that TAC has no y component. Nga naman because it is directed along the x-axis. Your TAB and your 600 newtons has a component of y. So that is why we have to account TAB and the 600 newtons sa ato pag-solve. So therefore, we have to use the summation of forces of y. So ato ipang-sum ang component sa atong y. So unsa may component aning atong TAB, unsa y component aning atong 600. Okay? And you are given a slope and an angle. So pwede na ni nato madiretso. When you are going to add a component, dapat magamit ka ng summation of forces of y and then mag-specify ka og unsa nga direction siya dapat positive. Okay? So, kaning pasabot aning nagbutang kog up, ako pasabot ani nga nagsum ko og forces sa y and then ako gi-assume nga ang direction sa pababaw mao na ang positive. Okay? So, therefore, kung ang direction sa y padung sa ubos, that is negative. In this case, this one is negative di ay, and this one is positive. Okay? Going up man ni atong TAB nga force. Okay? So, ato ibutang. TAB, unsa man ni siya? Sine or cosine, di ba? Adjacent over hypotenuse. So, this is cosine. TAB cosine of 30 degrees. And positive siya because it is going upwards. Then, minusan aning atong sa ubos, minus 600 times ang slope, which is, ang pa-vertical atong focus, so 3 over 5 is equal to 0. Okay? So therefore, your answer here, inig-add ni mo ana sa calculator, you will have an answer of 415.69 newtons. So we have this answer of 415.69 newtons, which means that your TAB has a magnitude of 415.69. And kaning atong equation dire, we have an unknown, and then we know that this equation is in equilibrium, therefore this is equal to 0. Then we have this unknown. Then by just manipulating the equation and transposing these known values to the other side, then you will get your TAB. Okay? Now, how about for our force TAC? Ma-determine lang ni nato if we are going to use the summation of forces along the x. Okay? So, kay nga naman, kay this is directed along the x-axis man. And, again, maghimo kog assumption nga ang positive na to nga direction is going to the left. So, ako indicate diri nga nagbutang ko og ing-ani nga arrow. So, ang pasabot ani again is positive ni siya nga direction. Wala to na ho gi-apply ang katong positive ang dapat naa sa right, positive na sa up, ug positive ang naa sa padong nako. Naghimo lang og assumption para mupareha siya sa akong unknown direction. Okay? Equals to TAC. And take note nga kaning atong TAC, wala na ni siya'y cosine or sine because this is directed along our x-axis or this x-axis here, parallel to our x-axis. Okay? So, wala na tayo sine or cosine. And then, alita sa TAB, minus, so atong gi-account tanan mga forces along the x. Kanina naman siya force along the x. Kani, naani siya force along the x which is kani nga component. Diba? So, kani nga component, mo ni iyang x component sa atong TAB. And also, we have an x component sa atong 600 newtons which is that one. Okay? So, we have to account all of that and we have to sum it using summation of force along the x. So, TAC minus una ta sa TAB which is 415.69. So, this is, di ba, parehara man magnitude ang kaning nasa baba o kaning nasa ubos. So, ato gamiton opposite over hypotenuse, that is sine of 30 minus kay, again, opposite siya sa atong direction nga gi-assume, minus ning 415.69 kay opposite siya sa atong direction gi-assume, kay padung siya dito, and kaning atong 600, padung po siya dito, that is why negative po na siya, minus 600 times 4 over 5 is equal to 0. So therefore, your TAC is equal to 687.845 newtons. So these are the magnitude sa forces anang atong duha ka cable. Okay? So if you are going to sum TAB, TAC, and this 600 Newton, dapat ang ilang sum is equal to 0. Okay, again, we are talking about equilibrium. And therefore, kung ayaw tag equal to 0 ni ang atong ring kay wala naglihok. Ang atong ring is static. Okay? So, mao nang inig-sum na to ni 600 plus 415.69 plus 687.845 dapat equal to 0 ang iyang answer, ana. Understood? So, I just hope that you have learned the concept of on how to create a free body diagram. And again, the only use of our free body diagram is to determine or to account all the forces that are acting on the object. So, ang imong unang buhaton is to draw the object, and ang second imong buhaton is to think about all the possible forces that is acting to that object. And you can now easily solve the problem. So, as a summary of this lesson, we have discussed the equilibrium equation, which is summation of forces. And we knew that when we are dealing with two dimensions, we have summation of forces along the x and summation of forces along the y, both equal to 0. Again, since we are dealing with objects that are static and they are not moving. Okay? We also have dealt with the free body diagram, and I hope you have learned how to create a free body diagram. And if you are still confused on how to make one, then there are a lot of tutorials on the internet for you to be able to understand how to create one. And lastly, you have known some of the kinds of supports that are supporting all these objects that we have here, all these bodies that we have here. Okay? So I hope that you have learned a lot in this lesson. This lecture was actually very long, and I hope nga wala mo na drain sa atong lecture karon. Thank you for listening. Thank you for your time, and see you on the next week. Peace.